As the stars in the night sky dim from the effects of modernity, such as light pollution, increased space debris, and satellites, we will be left with memories of constellations from which elaborate stories were woven. From Apis to Valons, each constellation inspired stories that are as old as they are culturally valuable. However, like the constellations, these ancient stories are fading with time. From the book The First Astronomers, star knowledge brings a sense of purpose, a sense of hope, a lifeline that each person is connected to the bigger whole, the stars, the universe. It's not like we're just outside observers watching this, we are a part of it. Follow me through space, time, and mythology as we explore constellations like Leo the Lion, Orion the Hunter, the Emu in the Sky, the Pleiades, and many others. On the way, we'll look at some interesting facts about the stars we are connecting. Since most cultures in the ancient world did not use written language, we will explore oral traditions as far back as possible. Some cultures have never used constellations as a mythological vehicle, and many we will never know about because they are lost to time and/or eradication. Nor did all cultures connect the starry dots in the same patterns. For example, when I talk about Leo the Lion, a completely different pattern may have been used in a society just 100 miles away. We will then travel to the stars most commonly associated with each constellation, examining details such as age, distance, formation, and known exoplanets. Leo the Lion. Leo the Lion's constellation has ruled the summer sky for thousands of years. Its brightest stars, Regulus and Algieba, have shone down on cultures ancient and modern, bringing order to the cosmos and the minds of humans. Let's look at this regal lion, its history, and the science behind it. Visible in the northern hemisphere during the spring and summer, Leo the Lion is one of the oldest known constellations. It was one of 48 constellations described by Ptolemy, while the modern count is up to 88. Although the name Leo was not always associated with this constellation, the lion is a common motif in the Middle East and in Europe. It contains several bright stars, including Regulus, sometimes called the heart of the lion. In ancient times, the lion was associated with the summer solstice and used by early farmers to know when to plant crops and possibly even for navigation. The ancients observed more than just stars in the lion. The planet Venus is sometimes at the forefront of the constellation. How far back can we trace these hints of star knowledge? The Lion Man sculpture, also known as the Stadel Cave figurine, is a small carving of a human figure with the head of a lion or a big cat. Discovered in the Stadel Cave in southwestern Germany in 1939, it may have been created by the prehistoric Aurignacian culture, which flourished in Europe around 40,000 years ago. The sculpture is made of mammoth ivory and is about 30 centimeters or 12 inches tall. The Lion Man sculpture is a precious relic from ancient Europe, offering vital insights into prehistoric art and culture. It is among one of the earliest depictions of a mythic object yet found. The sculpture's proposed astronomical significance comes from a series of lines and notches on its arms and back. Some have proposed that these markings represent a lunar calendar or a record of lunar phases. The sculpture also has several other markings that may have had astronomical significance, such as a series of vertical lines that could represent stars or a star chart. However, these interpretations are speculative and have not been and probably cannot be verified. The Lion constellation can be archaeologically dated to as early as 4000 BC in Mesopotamia. With the invention of writing, the Sumerians are credited as one of the earliest civilizations, dating to as early as 3200 BC. Eventually, they produced the Mul.Apin, a series of cuneiform tablets, with the earliest tablet dating to the 7th century BC, though it may have had its roots around 1350 to 1150 BC. It contains astronomical observations and predictions, including a list of stars and planets, each with a name and a brief description. The Sumerians' name for Regulus was Lugal, or Ur-Gu-La, translated as the star that stands in the lion's breast, the king. The Venus tablet of Ammisaduqa dates much earlier, from around the 17th century BC. It records the earliest known observations of Venus and includes its rising and setting. Though very detailed, some observations don't match what astronomers expect. Below is a link to a fascinating video that may explain this anomaly. A tablet from Nippur, also dated to around 1700 BC, contains a catalog of stories and poems, including Inanna's descent to the netherworld. This reference shows the story is quite old and evolved from oral tradition. Inanna, the Lion of Heaven, is often depicted standing on the backs of lions and symbolizes the planet Venus, which passes by Regulus about every 8 years. Venus rises in the east and is visible for 8 months and 5 days. It then disappears for 3 months, and so does Inanna, the goddess of love, war, and fertility. She was considered a trinity with her sister Ereshkigal, the goddess of death, and her husband Dumuzi, the god of rebirth. All three represent the cyclical nature of life. Almost certainly, in the old Sumerian system, would have represented Inanna and Ereshkigal, with Dumuzi, or his counterpart, the king in whom his spirit was incarnate. Sumerian culture was among the few who realized Venus was the morning and evening star. Other cultures worshipped or venerated the evening and morning stars as separate entities. For the Greeks, the goddess Aphrodite had nothing to do with the planet. The link was, in all probability, made as a result of Babylonian influence in astronomy. Here we see how the Sumerians mythologized the planet Venus's orbital motion, or more specifically, inferior conjunction.
Neti, the chief gatekeeper of the netherworld, answers pure Inanna. Who are you? I am Inanna towards the place where Utu rises. If you are Inanna towards the place where Utu rises, why do you go to the land of no return? Why do you take the road whose traveler returns not?
Dumuzi is actually listed as one of the early kings in Sumeria. According to the story, he was a consort to Inanna. While visiting her sister's husband, Gugalana, Inanna is judged by Annuna, a group of gods who decide fate.
The Annuna, the judges of the underworld, surrounded her. They passed judgment against her. No one ascends from the underworld unmarked. If Inanna wishes to return from the underworld, she must provide someone in her place.
For 3 days and 3 nights, Inanna's corpse hung on Ereshkigal's hook, but was saved by Ninshubur, Inanna's divine attendant, and Enki, the god of wisdom.
Walk on to your city, Inanna. We will go with you to the big apple tree in Uruk. In Uruk, by the big apple tree, Dumuzi, the husband of Inanna, was dressed in his shining me garments. He sat on his magnificent throne. He did not move, and the Gala seized him by the thighs.
According to the 3 faces of Inanna, an approach to her polysemic figure in her descent to the netherworld, Nippur is considered to be one of the most important and traditional religious centers of the Mesopotamian region during the 3rd and 2nd millennium BCE, and along with Uruk, the city of Inanna. In the east, Venus passes over or occults Regulus about every 16 and 24 years, with more extended periods in between. To the west, it seems to occur in 8 and 235-year cycles. So, as Lugal refers to Dumuzi, the king, Inanna can be interpreted as the king's wife and the throne upon which he sits, honoring the mysteries of life, divine law, and the political power she embodies.
Rituals are enactments of myths.
When Venus occulted Regulus, it may have represented Inanna's sacrifice of Dumuzi, and the rituals must have been lavish. Archaeological evidence suggests that her statue was finally dressed in Uruk, transported along a route through several cities, and then either disassembled or ritually destroyed in Kutha. The story possibly describes an aspect of Inanna's ritual.
Father Enki, don't let anyone kill your daughter in the underworld. Don't let your precious metal be alloyed there with the dirt of the underworld. Don't let your precious lapis lazuli be split there with the mason's stone. Don't let your boxwood be chopped up there with the carpenter's wood. Don't let young Lady Inanna be killed in the underworld.
Not too far away in Egypt, though the lion was recognized, the constellation was also called the Great Sickle, which rose in the east during the summer, indicating the annual flooding of the Nile River. Interestingly, Sekhmet, a lion-headed goddess, was the goddess of war and healing, to whom Egyptian physicians called to heal the sick. There may have been a symbolic influence at some time, but her myth is constructed from snippets of prayers, hymns, and spells from various items, so it is difficult to connect her to a particular astronomical object. There is no single unbroken source for Sekhmet. And to put this problem into perspective, ultimately this is what I found. The visible planets were known fully in Egypt from early times on. However, for a long time they played a rather minor role, especially being confined to appearing within the context of a decoration scheme aiming at assembling the important features of the night sky. A great deal of research still needs to be done concerning the question to which degree individual planets are mentioned in the text outside this image, and if there are specific terms for planets already in earlier times. In Africa, there are no known references to the constellation Leo, but if you know any, please share it in the comments. Venus, however, was quite an important figure, as in many cultures the evening and morning stars are seen as separate entities. From the Treasury of African Folklore by Harold Porlander, there is Cailagan, Venus seen in the morning, and by this star the Maasai knew that it is near dawn. Women pray to Cailagan when warriors are late in returning from a raid. And Lagan, Venus seen in the evening, which, when visible, is a sign that the moon will rise. Unfortunately, as we move to the Americas, there are precious few connections with this or any constellation because European colonization has systematically erased nearly all cultural information. However, as early as 1500 BC in Central America, the Maya recognized Regulus as single star. The adjacent constellation was called Kimi, or Death and Transformation. Venus, or Chek-Ek, was considered a force of nature associated with war, and its cycles were integrated into the Maya calendars. Another name for Venus was Rabbit, or Lammat, the symbol of fertility or a new beginning. The Dresden Codex carefully tabulated the planet's motions, and curiously, like the Tablet of Ammisaduqa, it contains similar observational inconsistencies. The Maya calculated Venus's motion better than any other known civilization at the time, showing that Venus's year lasts 584 days, which is accurate to within 2 hours. The Codex helped schedule Maya rituals, including human sacrifice, a motif shared by many ancient civilizations. This practice connects with a ball game we now call Pok-A-Tok, an onomatopoeia for how the ball sounds when hitting the court floor. But we don't know any references to the names played back then in the Maya literature. Ancient Astronomy, an encyclopedia of cosmologies and myth, states, there was also a clear association between Venus and the sacred ball game played throughout Mesoamerica. The game was also a ritual portraying the twins Hunahpu and Xbalanque as they played against the gods of the underworld as described in the Popol Vuh. The ball contained 2 stone hoops. Each team aimed to shoot a rubber ball through the hoop to score a point. The ball represents a human head and vice versa. Each team, one representing Venus and the other the underworld, plays in synchrony with the hero twins. According to the Maya archaeologist website, supporting evidence is that all members of one team wear water lily headbands, an underworld symbol, while most members of the opposite team wear spiral or cross-section shell pectorals, a documented symbol of Venus.
The head of Hunahpu was first placed atop the ball court, but Hunahpu just called out, "Strike the head as if it were a rubber ball." Thus the lords of Xibalba threw down the ball, where it was met by Xbalanque. The ball landed before his yoke and bounced away, landing in the tomatoes. Then the rabbit came out, hopping along. All the Xibalbans thus went after him. The Xibalbans all went after the rabbit, shouting and rushing about.
Rabbit, or Lammat, is a strong character in the Popol Vuh, and is germane to the story of Hunahpu and Xbalanque in interesting ways. However, Lammat's direct connection to Venus seems well hidden. As Inanna journeys to the underworld, so do the twins. The cycle of life is acknowledged and celebrated by the heroes of each story. Inanna's sacrifice of her husband Dumuzi, and Xbalanque's sacrifice of Hunahpu with the promise of life's renewal. Hunahpu shares the death and resurrection just as Venus or the moon. Each disappears and then rises again. The scattering of seeds in the underworld is a triumph of life over death. Thus, our hero twins, Xbalanque and Hunahpu, are victorious.
And so they began again to play ball, both teams making equal plays, until at last Xbalanque struck the chilacayote squash, strewing it all over the ball court. Thus, its seeds were scattered before them.
Though many stories claim the game sacrificed the team leader, this isn't always true. Neither the winners nor the losers were sacrificed during the Maya ball game, with the exception of a game that took place instead of going to war against the city. In this instance, teams from both cities would play each other, and the leader of the losing team may be killed, although often they were allowed to live as long as the losing city would supply the winners with a quantity of jade, obsidian, or other special goods. Though complex, the Popol Vuh gives us a peek into the myths and rituals of the Maya. There is still so much to learn about this rich and complex society, some of which we may never know. We can now look at the Lion Constellation with modern technology and explore the details of the stars. The International Astronomical Union, IAU, states, tracking stars and their attributes or cataloging stars has a long history. Since prehistory, cultures and civilizations worldwide have given their own unique names to the brightest and most prominent stars in the night sky. There is also the Working Group on Star Names, or WGSN, which means there may be several names for each star, but let's not get too caught up in the names.
I said it wasn't important.
The goal here is to point to a star and understand the process it's going through. The Leonoid meteor shower is a debris field from the comet Tempel-Tuttle. Appearing as though it's coming from the constellation Leo, bits of dust and small rocks burn up in our atmosphere, providing a beautiful display for we Earthlings. It peaks annually from about November 17th and 18th and radiates across near the bright star Gamma Leonis. The January Leonoids are a minor shower that peaks between January 1st and 7th. Though not as spectacular, it never hurts to look up. In my research, I was surprised that Venus was a prominent star in the Lion constellation. So let's see what this wandering star offers our curious minds. Venus, often considered the sister planet to Earth, is a mere 405 miles or 652 kilometers smaller than our planet. Because it is a little smaller, astronomers are keen to study Venus and its atmosphere. Unlike Earth, Venus has no moons, and the sun rises in the west and sets to the east as it rotates backwards. Venus is the brightest object in the sky after our own moon. It orbits the sun at about 67 million miles, or 108 million kilometers. Like our moon, Venus has phases. The complete cycle takes 584 days. Venus's surface has valleys and high mountains dotted with numerous volcanoes. Some of its surface features are named after mythical women, including Ishtar Terra, a rocky highland area around the size of Australia near the North Pole. Larger still is a South America-sized region called Aphrodite Terra that extends along the equator. Venus is hotter even than the innermost planet Mercury. The atmosphere is mostly carbon dioxide, the same gas driving the greenhouse effect on Earth, with clouds composed of sulfuric acid. The planet does not have its own internally generated magnetic field. Instead, Venus has what is known as an induced magnetic field. This weak magnetic field is created by interacting with the Sun's magnetic field and the planet's outer atmosphere. First star we'll examine is Alpha Leonis, or Regulus, Latin for Little King. Regulus is the brightest star in the constellation, about 79.3 light-years away. At least 1 billion years old, it is the primary star in a quadruple star system consisting of at least 2 pairs of stars. Astrophysicist Faith Hawthorn explains.
Astronomers have been trying to understand how these multiple star systems are formed. A cloud of gas and dust may fragment into multiple clumps, each of which becomes a star. Or perhaps an individual star may capture another in its gravity. We still have a lot to understand about how these formation mechanisms work, but still astronomers are making more observations to help solve this puzzle.
As temperature increases, stars will shine from red and cooler temperatures to a hyper-intelligent shade of blue at higher temperatures. So a 3000 K star will look red, and a 30,000 K star will look extremely blue. With a combined apparent magnitude of 1.4, remember it's a quadruple star system, it is the brightest star in Leo and the 21st brightest star in the sky. Absolute brightness is the actual luminosity of the star from about 10 parsecs, or 32.6156 light-years away. Apparent brightness is how bright it looks from an observer. In this case, that's us. The scale is inversely proportional to the brightness, which means the brighter an object is, the smaller the number, even down to the negative numbers. Knowing both can give the distance of the star. Regulus shines 316.2 times brighter than our Sun, with a surface temperature of 11,668 Kelvin, giving it a blue color. Despite being 3.8 times more massive and 4.35 times larger than the Sun, it rotates at a staggering 318 kilometers per second, while the Sun's rotation is a mere 3 kilometers per second. No exoplanets have been found around Regulus, although it is theoretically possible for a planet to orbit a quadruple star system. Eta Leonis, or Denabola, is a star that bears the name Tail of the Lion, in reference to its celestial position. Alongside the brighter Regulus, it takes place among the 58 stars used for naval navigation. Denabola showcases its uniqueness as a delta Scuti variable star, which means it appears fainter, has a smaller mass, and experiences shorter pulsation periods than a Cepheid variable star, fluctuating in brightness about 0.025 magnitudes, about 10 times per day. It marks one of the vertices of the Great Diamond, also known as the Diamond of Virgo, a captivating group of stars that graces the spring sky. Denabola, less than 400 million years old, spans about 2,118,768 kilometers across and sits at a distance of 35.9 light-years from our vantage point. With a blue glow, its temperature reaches about 8,500 Kelvin. This star has inspired sailors and stargazers alike throughout the ages. No exoplanets have yet been found in this system. Gamma Leonis, also known as Algieba, stands as a prominent binary star with an apparent magnitude of 2.08, making it the second brightest star in Leo, trailing only Regulus. This captivating duo consists of two giants, Gamma 1 and Gamma 2, gracefully orbiting each other for a lengthy 510.3 years at an average distance of 170 astronomical units, a smidge larger than our solar system. Their orbit is highly oval, bringing them within 23 AU, just a bit closer than the asteroid belt is to our Sun. With the aid of larger binoculars or a small telescope, we can witness the brilliance of these stars. Gamma 1 Leonis, with an apparent magnitude of 2.37, shines in an orangish-red hue with an effective temperature of 4,470 Kelvin. This red giant shines 320 times brighter than our Sun, while measuring 1.23 times the Sun's mass. Around Gamma 1 Leonis, an exciting discovery was made on November 6, 2009. A planetary companion. In Wu Han et al. Detected this intriguing planet using the radial velocity method, which detects a wobble in the star's light caused by the Doppler shift. Named Gamma 1 Leonis b, it boasts a mass of approximately 8.78 times that of Jupiter and orbits its host star at a distance of 1.19 astronomical units, taking a mere 1.2 years to complete a full orbit. The same team may have discovered a second planet, but that must still be confirmed. In the meantime, let's take a look at Delta Leonis, also known as Zosma, a star with a Greek origin meaning the girdle. It twinkles from 58.4 light-years away from Earth. As a white subgiant star, Zosma is twice the size and mass of our Sun, boasting a radius equivalent to 2.14 solar radii and 2.2 solar masses. With a bluish-white hue, its effective temperature is 8,296 Kelvin. This speedy spectacle rotates 90 times faster than our Sun, taking less than a day to complete a full rotation, while the Sun takes a leisurely 27 days. This celestial wonder is aged around 600 to 750 million years. However, as Faith Hawthorn says, Age is hard to calculate. It usually depends on the star's rotation period or studies of chemical abundances, but difficult to pin down reliably. No exoplanets have yet been found in this system. Epsilon Leonis, or Ras Elased Australis, known as the head of the lion, is located about 247 light-years away with a temperature of 5,281 Kelvin. It is a G2 yellow giant star that shines with a yellowish color. It's bigger and brighter than regular stars like our Sun, but not as massive as supergiants. These stars are most of the way through their lifespan, having expanded after using their core hydrogen fuel. Ras Elased Australis shines as brightly as 288 suns and has a radius approximately 4 times larger than our Sun. Despite its captivating presence, no exoplanets have yet been found in this system. Zeta Leonis, or Adhafera in Arabic, shines brightly with an apparent magnitude of 3.33 and resides 274 light-years away from Earth. As a giant star, it's 3 times more massive than our Sun, with a radius 6 times larger and an effective temperature of 6,792 Kelvin, giving it a yellow-white glow that's 85 times more luminous than our Sun. Originally a Class A main sequence star, it evolved into a giant within the last million years. In the next million years, it will become an orange giant, and over the following 100 million years, it will expand further, becoming a red giant. Instead of a supernova, it will eventually cast off its outer layers and transform into a faint white dwarf. No exoplanets have yet been discovered. Eta Leonis, known as Algieba, lies approximately 1,270 light-years away. It could be a binary star system, but this has not yet been confirmed. To put this star's brilliance into perspective, our Sun boasts an absolute magnitude of 4.83, whereas Algieba's absolute magnitude shines at an impressive negative 5.6, nearly 20,000 times more luminous than our Sun. No exoplanets have yet been discovered. Zeta Leonis, also known as Coxa, is a grand star with an impressive 2.5 times the mass and a luminosity that shines 141 times brighter than our Sun. With a scorching temperature of 9,350 Kelvin, it emits a blue glow. Coxa has graced the cosmos for about 550 million years. What makes this star even more fascinating is its classification as a chemically peculiar A-type star containing metals other than hydrogen and helium. Astronomers use a different definition for metals. Anything heavier than helium qualifies. Resting 19.76 light-years away, Coxa's system remains uncharted territory as no known exoplanets have been discovered. Mul.Apin, also known as Rasalas, is a red giant star that graces our night sky. It has a surface temperature ranging from about 3,500 Kelvin to 5,000 Kelvin. With an apparent visual magnitude of 3.88, it is 106 light-years away. With an orangish glow, this star shines an impressive 63 times brighter than our Sun, with an effective temperature of 4,436 Kelvin. Approximately 3.35 billion years old, Rasalas witnessed the eons pass by. In 2014, B.C. Lee and collaborators made an exciting discovery, an exoplanet called Mul.Apin b. This gas giant planet is at least 2.4 times the mass of Jupiter and completes its orbit in 358 days. Similar to Earth's orbit around the Sun, its distance from Mul.Apin is approximately 1.1 AU. The discovery was made using the radial velocity method, which detects a wobble in the star's light caused by the Doppler shift. While no other planets have been found in the system yet, the list of exoplanets is growing daily, with over 5,000 exoplanets discovered so far.